these are the notes for lesson 3.3, graphing and solving systems of linear inequalities. If you recall, when we graph an inequality, we first need to graph just like we would a line. So this is the same as y equals 2x minus 5. We would graph that line by first starting with our y-intercept of -5. We then use our slope to find the next point on our line. So we had y-intercept and slope. And then we would draw our line. Now, we'd have to determine whether it was a dashed or solid. So it's less than or equal to, so that would be a solid line. And we are shading below because it's less than. We're going to do the same thing with systems of linear inequalities. We're just going to graph each inequality at a time and then see where they're shaded together. So our first example says to graph the following system of inequalities. So like I said before, we're going to take each inequality and graph it separately and then look at where they're shaded together, and that is our solution to the system. So our first inequality is y is less than or equal to 1/2 x plus 2. So again, graph this just like we would any other line. So we're going to start at 2, which is our y-intercept. Then from there, we're going to go up 1 and over 2 because this is our slope. So up 1 over 2. Again, we can put multiple points on our graph, and notice it is a solid line because it's or equal to. Then we need to shade. It's less than or equal to, so if we put our pen on the line, we're going to shade below the line. Then we're going to look at our second equation. We have 2x plus y is less than 4. We can change this to slope-intercept form by subtracting 2x. So y is less than negative 2x plus 4. And we'll graph this as well. So we're going to start at 4, which is our y-intercept. And our slope is -2. So we're going to go down 2 and to the right one, because remember this is -2 over 1. Again, we can put multiple points on our line. And we know that this is going to be a dashed line because it's not or equal to. And the last thing we need to do is shade. So again, if we put our pen on our line, we have less than, so we're going to shade below. Now when we have multiple systems, our solution set is where they're shaded together. So if we look at our graph now, they're shaded together in this area right here. So our solution to these two inequalities is this black shaded section. And just like we did with systems, if we were to plug in a point in this black shaded area, it should work for both inequalities. If we plug in any other point, it won't work for both, it will only work for one or the other. So the next part of our example is to determine whether the following ordered pairs are solutions to the system. So the first point is 2, 3, that red dot right there. Notice it is not in the shaded area, so it is not a solution. Our next point is 1, -1. So if we go to the left one and down one, notice it is in the shaded region, so it is a solution. The next point is -4, 0. So we're going to go to the left 4, the purple point right here. Notice it is on our solid line, and it is right above the shaded area, but we know that this line is solid, so therefore it is a solution. So this one is yes. And lastly, we have 2, 0. So we're going to go over 2 right here on this white spot. Notice it is on the dashed boundary. Since it is on the dashed boundary, 2, 0 is not a solution. If it were a solid line, it would be, but since it's a dashed line, it is not a solution. So again, the solutions are going to be in the shaded area. If they're on the boundaries, they are solutions if it's a solid line. They're not solutions if it's a dashed line. So the solution to a system of linear inequalities is an ordered pair or a coordinate that is a solution to both inequalities in the system. Again, it has to be true for both inequalities. The graph of a system of linear equations is the graph of all solutions of the system. They will be represented as a shaded area of possible solutions. So again, where both inequalities meet, where their shaded regions are both shaded together, that is the solution to a system of inequalities. Let's look at another example. The two inequalities that we have here are x minus y is less than 2, and x is greater than or equal to -2. So for the first equation, let's first change it to slope-intercept form. So first let's subtract x, so we get -y is less than -x plus 2. Now this is a -y and we want a positive y, so we're going to multiply everything by a -1, so this will make y positive. Remember, whenever we multiply by a negative, we have to switch our symbol. So this becomes greater than, our x becomes positive, and 2 becomes a minus 2. So now let's graph. We start at negative 2. So again, that's our y-intercept. Our slope here is 1 over 1. So we go up 1 over 1. You can also go down 1 to the left 1. And our line is going to be dashed. And then we just need to shade. Our symbol is greater than. So if we put our pencil on our line, we are shading above the line. Then let's look at our second inequality. We have y is greater than or equal to negative 2. We have x is greater than or equal to negative 2. Think of this as x is equal negative 2. We know that this is going to be a vertical line through negative 2. So we go to the left 2, and it's going to be a solid line through negative 2. And then we shade. Again, it's greater than, so that means that we are shading to the right. Now to find the solution for our system, we need to look at where they are both shaded together. So it's going to be the black shaded region. That's where they both are shaded together. So that is our system. So any of the points on that part of the graph could be a solution for this inequality. So I want you to think, will there ever be a system of linear inequalities with no solutions? If so, give an example. I want you to think about this and write down what you think. Think about our special types of lines. Will there ever be a system of inequalities, so two inequalities, that will not have a shaded area together? And we'll talk about this in class tomorrow. Example 3 says, graph the following system of inequalities. We have negative 2 is less than or equal to y is less than 4. We know that this is a compound inequality, so it's two inequalities together. So we know that y is less than 4 is one of our inequalities. And we know that negative 2 is less than or equal to y is our other inequality. Now whenever we write inequalities, we always want the variable to come first. So if we switch the order for this one and bring the y first, for negative 2, we have to switch the sign as well. So instead of less than, it's going to be greater than or equal to negative 2. And then we just need to graph these. So we'll start with y is less than 4. Again, think of this as y is equal to 4. Remember our vertical and horizontal lines. So hoi and vox. So hoi or horizontal is y equals. So y equals 4 is a horizontal line through 4. So we go up to 4. It is less than 4, so it's going to be a dashed line shaded below. Our second inequality, y is greater than or equal to negative 2. Again, it's going to be a horizontal line because it's y equals. So we're going to go down to negative 2, and it's or equal to, so it's going to be a solid line, and it's greater than or equal to, so we're going to shade above. So again, our solution area is going to be the area between these two horizontal lines. So our black shaded region is where our solutions will be at. Example 4 says, graph the following system of inequalities. If you remember, a system of equations is just one or more equations together. So the same thing is true with inequalities. So it doesn't have to be just two inequalities, it could be more than that as well. So we can do the same thing with inequalities as well. So we just have to graph all three of them together, see where all three are shaded in the same region. So we're going to start with our first inequality here. We have 2x minus 3y is less than or equal to 12. Again, we want to change this to slope-intercept form. So we're going to subtract our 2x. So negative 3y is less than or equal to negative 2x plus 12. And divide by negative 3. And y, again, we need to change our inequality sign or switch it. So it's y is greater than or equal to. And a negative is a positive, so this is a positive 2/3 x. And 12 divided by negative 3 is a negative 4, so this is going to be minus 4. So let's graph that. Start at negative 4. We're going to go up 2 over 3, and this is going to be a solid line. It is greater than or equal to, so we're going to be shading above the line. Our second equation, or inequality, we have x plus 5y is less than or equal to 20. Again, we want to subtract our x's first. So we have 2y is less than or equal to negative x plus 20. Divide by 5. Y is less than or equal to negative 1/5 x plus 4. So we're going to start at positive 4, and our slope is negative 1/5, so we're going to go down 1 to the right 5. We have less than or equal to, so again it's going to be a solid line. And we are shading below because it's less than. We're just going to go and extend this green line just because they will intersect. And then our last inequality is x is greater than 0. This is the same as saying x is equal to 0. So again, we know that this is going to be a vertical line through x equals 0. So that's going to be our y-axis. And it's going to be a dashed line because it's just greater than. So we are shading to the right. Now we need to look at the area where they are all shaded together. So all three are shaded in the same part. So we know that that's going to be this triangle right here. So again, the black shaded area is our solution for this system of inequalities. In our last example, we are writing the system of inequalities that is graphed below. So now they give us the graph, we need to write the equation. So first, it doesn't matter what line we start with, but notice that there are two lines here. So I'm going to start with this line right here. We know that this is a vertical line through x equals 2. So we know that this is the equation x equals 2. Now it's a solid line, so we know that whichever inequality we use, it's going to have to be or equal to. And if we look at our shaded region, it is shaded to the left of the line. Or we're looking at the shaded region to the left. So that's going to be less than. So the equation for this one is x is less than or equal to 2. Then we need to look at our second line here. Notice it is a dashed line. So this time it's either going to be less than or greater than, not or equal to because it's dashed. And we need to find the equation for this line. So we first need to find our y-intercept. Notice that the line crosses the y-axis at 0, and our slope is down 1 over 1, so that would be a negative 1. So our equation is y equals negative x plus 0. Now we just need to figure out which inequality we need to use. Notice that we are shading above the line, so that is going to be greater than. So the equation for this one is y is greater than negative x. And then we write systems inside a bracket. So this system of equations is y is greater than negative x, and x is less than or equal to 2. It does not matter which order you write the equations in, as long as you have both correct inequalities. So again, we can graph systems of inequalities just like we do equations. We're just looking for the shaded region, and that gives us our solution, instead of just looking for the intersecting point like we did with lines.